This is a guide to setting test limits on the CITS880s PCB controlled impedance test system. Once you've taken a look at this guide, you'll have a better understanding of how to set the test limits on an ideally designed test coupon, how to set the test limits where the coupon is less than ideal, and what to do when an OEM asks you to set test limits in a certain way, and how you should communicate with the OEM if you want to alter those limits. So let's get started. I'll look into this using a specially designed test coupon which has got ideal traces and also some intentionally compromised traces. There are plenty of examples on this coupon, but for this video I'll focus on just 3. The first is a 50 ohm trace with a good launch and a good exit to show you what you should expect to see in an ideal situation. The second is another 50 ohm line with a major discontinuity quite close to the end, and this has been designed to show the effects of a poorly designed coupon termination with a bad via or a thick board with wrongly designed anti-pads at the end of the trace. And the third example is another 50 ohm track. On this one there's a major discontinuity close to the start of the trace, and it's hidden away underneath the via. You can just about see the via under the highlighted area of the coupon. Remember that all 3 50 ohm traces here have identical cross sections. The difference is in the end and the start. Let's move into the CITS software and test them first on a setup where I leave the test limits the same and set the waveform overlay so you can see how the response is different in each case. So, setting up 5 overlay waveforms first, I'll test an open circuit. You test an open circuit first to see the probe length is set correctly on the CITS. I'll then move on to testing the straightforward 50 ohm trace with a good launch and good termination. Then follow on by the other 2 traces. So there's the trace of the 50 ohms. You can see it's flat and undisturbed throughout the test area. I'll then move in and test the next trace, and when you see the waveform appear, you can see at the start of the waveform there's a dip in it. You can see the ripples from the dip do settle out by the end of the trace, and on this third coupon I'll test the trace with the discontinuity towards the far end of the trace, and you should be able to see the resulting dip at the end of the waveform. So here's the trace with the discontinuity at the end. You can see the dip right at the far end, and you can see that on all 3 waveforms there are flat regions that you could use. The best, longest undisturbed region is the one with a good launch and good termination. But I'll turn the overlay off and show you how to set the test limits to get the best out of each of these 3 instances. I've cleared the waveforms from the CITS, and the 50 ohm test has got a default test limit set over the widest area of the flat trace from the end of the probe to the end of the coupon. Then for the trace with the discontinuity at the start, I've moved the limits along to the end. So you can see here there's a bump at the start of the trace, but I've moved the limits across to between 6 and 7.5 inches, and it gives us enough of a flat area to move the test area out of the way of the discontinuity. And then the third test is to move the test limits across to the left, because in this situation you'll see the discontinuity is at the right hand side of the trace. Looking again at the ideal trace, the 50 ohm trace with a good launch and a good termination, let's say this situation is where a third party has specified the test limits for you. They might be set to a specific percentage between the start and the end of the coupon, and you can use a number of different ways to do that. You can snap to a percentage between the cursors, you can snap exactly to the cursors, or you can manually use the test editor to add those limits by simply typing in the number of inches along the coupon where you test. I'll test the 50 ohm trace, and you can see the test limit set here. If we right click, you've got a couple of choices: snap limits to cursor and percentage between cursors. And here I can snap to between, let's say, between 30 and 70% distance between the cursors. So just to confirm, in that case I've snapped the limits to between 30 and 70% between the cursors, or I can go back and snap directly to cursor. I'm now going to show an example where I set the cursors at the start and the end of the coupon. So the left hand is at the launch aberration, the right hand is at the open circuit, and now I'll right click and snap to cursor. So this tests over the whole length of the coupon. Now you've got the test limits set to look at the whole length of the coupon, and you may want to go and reset the limits again to a specific percentage between the start and the end of the coupon. Once again, right-click the menu, snap to percent between cursors, and again, we'll set to between 30 and 70%. Here you've got the limits you intended. So it's very easy to set up. If an OEM specifies the test limits to be a certain percentage from start to end of the cursor, use snap to set that percentage. The IPC also specify test limits in similar ways. You may find when you're doing this, the CITS auto scales the horizontal, and it can be quite distracting because each time you set the limits, the CITS will often zoom in to look at an area of interest and the acquisition needs to be retaken. And you'll need to rerun the test with a different horizontal scale. So what I find most convenient to do is when you're experimenting with test limits is to go in and edit and physically set the display width to a number of inches. There's a drop down here, the default will auto scale, or in this case, we've got a 10-inch window width, so I'll set the window to 10 inches, and while you experiment with setting the test limits, this will stop the auto scaling from happening in the horizontal and make it much easier to experiment. Finally, I'd like to draw your attention to the test method, and you'll see there are three: average, absolute and envelope. And I recommend that you use absolute in 99% of situations. Application note AP8515 goes through the methods in more detail. Average is a legacy method which was used for backplane testing. Absolute is the recommended method, and envelope is for more specialized applications. Application note AP8515 also explains the use of launch point extrapolation, which is a good technique if you've got narrow traces or very thin copper. Well, thanks for watching this brief introduction to setting test limits on the CITS880s. And if you've enjoyed this video, please do subscribe to the Polar YouTube channel. And if you'd like further information, you can find that on our website, or you can speak to your local Polar office, and the information for contacting them is shown on the following slide.